My name is Sadbir Singh Malli. In this video, the topic of our discussion is increasing and decreasing functions. Here I have the graph of some increasing function, and we can notice that if I draw a tangent line at any point of the graph on the graph of the increasing function, the slope of that tangent line will be always positive. So this will implies that the increasing function has this property that its derivative is always strictly positive. Similarly, if I take some decreasing function and draw the tangent line, and I will notice that the slope of the tangent line at any point on the graph of this function are negative. Therefore, the derivative of the function when the function is decreasing is always strictly negative. There I have another definition which called the critical values. The critical values are those values where either the derivative of the function is zero or the derivative of the function does not exist. Here in the next example, we will calculate the critical value of the function, and also we will calculate the interval of increasing and decreasing of the function. So let's start. So in step number 1, we will calculate when the function is, what are the critical value of the function. So find the critical value, find the critical values. To find the critical value of a function, we first have to calculate the derivative of that function. So let's see what is the derivative of this function. So f prime of x is equal to 2x minus 3 using the power rule. So now the critical values are the value where the function is either 0 or it does not define. Because this function is a polynomial, it is always defined. So we will just check the one condition that when the derivative of this function is 0. So we will plug 2x minus 3 is equal to 0, which is the derivative of the function. This will give us x is equal to 3/2. So that 3/2 is our critical value. So if I box this one, so this is the first answer is, this is the critical value. In step number 2, we will test this critical value to find the interval of increasing and decreasing. So our step number 2 is the line test. The line test. So what is a line test? It is a method which we test on the critical value of the derivative of the function. We apply that test to the derivative of the function. So derivative of the function, I will write it on here, is equal to 2x minus 3, and the critical value is a 3/2. So we will choose one point on the left of this critical value, which is, I can choose any point. I will choose 0, and I will pick a one point on the right side of the critical value, which I can choose as a 2. If I plug these point into the derivative, I will check what are the sign of the derivative. So the sign of the derivative when I plug 0 is a negative, because 0 minus 3 is minus 3, that's negative. And the derivative on 2, if I plug 2, is going to be a 4 minus 3, which is going to be a positive 1. So this is the positive. So the line test tell us these two information, minus infinity to 3/2, the derivative f prime of the function is strictly negative, and 3/2 to positive infinity, the derivative of the function is strictly positive. So based on this, we can make some conclusion here. So f will be, we say f is increasing, will be 3/2 to positive infinity, because this is the point where the derivative of the function is positive. So f is decreasing. If minus infinity to 3/2. So I will box my this answer. Let's take one more example where we can where we will find the interval of increasing and decreasing. In this slide, I have two more example. So I'm gonna start with the first one. So again, in the solution for the first one, we have two steps. Step number one, we will find the critical value, and in this step number two, we will do the line test. So step number one is calculating the derivative of the function. So f prime of x is equal to, in this situation, is going to be 6x square minus 6x minus 6. I will simplify that, minus 12, sorry. I will simplify this one a little bit. I can pull out 6. It's going to be x square minus x minus 2. So I will put the derivative is equal to 0 and find the critical value. So it's going to be 6 x square minus x minus 2 is equal to 0. If I factor this polynomial, it's going to be x minus 2 x plus 1 is equal to 0, because minus 2 plus 1 is a negative 1, and this multiply by that is a negative 2. So this implies x is equal to either 2 or negative 1. So these are the two critical value of this function is. Now we will do the line test. So line test is you simply draw a line and you plot these points on the line, -1 and +2, and then we will write down the derivative of the function here. F prime of x is you can say 6. We can write the simplest form, 6x minus 2 x plus 1. So this is the simplified version of the derivative. If I choose a point here, let's suppose I choose -2 and plug that -2 into the derivative. So what I get at -2, I will get that this is a -4. So 6 times -4, and if I plug -2 here, I get just 1. So this is going to be -24. So which is a negative number. That's all I care. Then I will choose a point 0 here, because it's easy to calculate the value at 0. The function derivative at 0 is simply 6 times minus 2 plus 1, which is a minus 12. So this is a negative sign here as well. -4, sorry, this is a -1. So this gives me a positive sign here. So sorry, this is a positive sign, and this gave me a negative sign here. And if I choose a point like, let's suppose 4, and plug that into the derivative function, so let's do that. F prime evaluated at 4 will be 6 times 2, and that will be 5. So that's definitely a positive number, so I get a positive sign. So derivative of the function, so I can conclude that f is increasing. F is increasing on this interval minus infinity to -1, because this is the interval where the derivative of the function is a positive, and also this interval -2 to 4, so 2 to infinity, sorry, and therefore I put that u sign. That means I combine these two intervals, and f is decreasing on this interval, which is in -1 to 2. Okay, let's move to one next problem. This problem is also we will do in two steps. The step number 1, we will calculate the derivative of the function f prime of x is equal to 3x plus 1, the square of that minus 3. Therefore, f prime of x is equal to 0 will gives me 3x plus 1, the square of that minus 3 is equal to 0. This implies x plus 1 square of that is equal to 3, and 3 will be divided over. I'm gonna get x plus 1 square of that is equal to 1. So this implies x plus 1 is equal to either 1 or x plus 1 is equal to -1. So this implies x is equal to 0 or x is equal to -2. So these are my two critical value, x is equal to 0 and x is equal to -2. Let's do the step number 2, which is a line test. Step number 2. You can do the line test here very quick. We have a 0 as a critical value and we have a -2 as a critical value. Let's see what is the derivative of the function. This is basically 3x plus 1, the square of that minus 3. If I plug any number which is less than -2, I can choose -3. If I plug -3, is gonna be always a positive number, but it is going to be, if I plug here -3, is gonna be a 3 times -2 square minus 3, which is basically 3 times 4, 12. So 12 minus 3, which is 9. So that's give me a positive number. And if I choose a point in between, let's suppose -1, and I plug that into the derivative. If I plug -1, this is a 0, so it's gonna give me a negative value. If I plug some point here, let's suppose 1, that's gonna give me 2, and 2 square again 4 times 3, 12, and this is gonna begin positive 9, so that is a positive. So this is tell me f is increasing. F is increasing on that interval -infinity to -2 union 0 to positive infinity, and f is a decreasing on that interval -2 to 0. So simply is basically the negative interval gives you decreasing, positive interval gives you the function is increasing. Okay, step number 1, we will calculate the derivative of the function. So problem number 4. What is the g prime of x? G prime of t, because the function is in t variable, is also going to be the product of two functions. So we will use the product rule. We have, and then t plus 4 plus e to the power 3, 4, and dy by dt of t plus 4. So this gives me 3/4 t to the power -1/4. If you subtract 3/4 minus 1, it will give you -1/4, and this is a t plus 4. This is a t to the power 3, 4, and the derivative of this term is just 1. So next thing is we need to simplify. This term will become 3 times t plus 4, and this term will become 4t to the power 1 4. And that term is basically t to the power 3 4. So if I make the same denominator here by multiplying 4t to the power 1 4 and 4t to the power 1 4, this gives me 3t plus 12 plus 4 times t, because t to the power 1 4 plus t to the power 3 4 is just t, and divide by 4t to the power 1 4. And this will simplify to 7t plus 12 divided by 4t to the power 1 4. So for critical value, we will put the top is equal to 0, ct plus 12 is equal to 0, and 4t to the power 1 4 is equal to 0. So the critical values of minus 12 over 7 and t is equal to 0. So the line test, the next step is we will do the line test. Before we do the line test, you need to be noticed that the domain of this function is only from 0 to infinity, because t to the power 3/4 is only defined when you have a positive value. So all the even fraction, all the even exponent which are evens, exponent 1 over even number, is only defined on a positive value. So our interval of increasing and decreasing will only start from 0. And since minus 12 over 7/2 is outside of interval, so this critical value we will not consider. We will only consider one point here, which I can, like, suppose I can take 1 and plug into the derivative. That is the f prime of 1. If I calculate, this will be 19 divided by 4, which is a positive number, so it's a positive. So the function is always increasing, so f is increasing on that interval 0 to positive infinity. So it's very important that you calculate the domain of the function, so that this value which we calculated by calculating the derivative of the function, even the critical value does not fall in the domain of the function. So this is will not consider when we calculate the increasing decreasing. So this function is always increasing. Next, I have two more examples. Problem number 5. Let's take the step number 1 to calculate the derivative of that function. So h prime of x. So we know that the derivative of a logarithm of u d over dx of that function is u prime over u. Here our u is this. So it will be u prime 2x minus 1 divided by u, x square minus x plus 2. So for critical value, we will put the top and bottom both is equal to 0. So 2x minus 1 is equal to 0, and x square minus x plus 2 is equal to 0. That will give you x is equal to 1/2, and this value gives you, if I use the quadratic formula, so 1 plus minus b square 1 minus 4ac, which is 8, and divide by 2a. So that's giving me basically non-real root, negative sign, so no real root. So no critical value here, so only critical value is x to the power x is equal to 1/2. In step number 2, we will do the line test. So let's do the line test with the 1/2 because we have only one critical value. If I choose a point on the left side of 1/2, let's choose 0 and plug that into the derivative of the function f prime of x, which is equal to 2x minus 1 x square minus x plus 2. So that gives me -1 over 2, so basically -1/2. So here the value of the derivative is a negative, so function will be decreasing. And let's choose a value which is greater than 1/2, which is we can choose 1. If I plug 1, I can definitely get a positive number. We can check that calculation, and that's give you basically the function is positive. So f is increasing on the interval 1/2 to plus infinity, but f is decreasing minus infinity to 1/2. Let's calculate the last one, which is involving the trigonometric function, problem number 6. So step number 1 for the problem number 6 is to calculating the derivative of the function. So f prime of theta will be 2 times minus sine theta, because the derivative of cosine theta is a minus sine theta. Derivative of this function is by using the chain rule. So 2 will drop. It's gonna give me a cosine theta. 2 minus 1 is 1. And then the derivative of inside, so it's going to be a 2 minus 1, and then the derivative of inside is outside, which is a sine theta with a negative sign. So I can pull out 2 negative sine theta from the both expression. So it's going to give me a 1 plus cosine theta. And if I put these two values equal to 0, so if I put the derivative is equal to 0, it will give me 2 sine theta times 1 plus cosine theta, both are is equal to 0. So therefore that gives me sine theta is equal to 0, and or cosine theta is equal to -1. You know that the sine theta is equal to 0 is 0 at pi and 2 pi, and cosine theta is equal to -1 is at pi and 3 pi, 4 pi, but these are the outside of the interval. So only the critical value which are inside the interval are basically 0, pi and 2 pi, where 2 pi is the end point and pi is the same thing number. So we will do the line test, step number 2. So line test is this. So you have interval now starting from 0 ending at 2 pi, and then there is a pi here. So you pick a point here and then you pick a point here. I can pick point let's say pi by 2 and plug that one into my derivative f prime of theta. And if I pick the point pi by 2 and plug it here, so let's calculate the derivative of the function at pi by 2. So f prime at pi by 2, that will be sine pi by 2 is a 1, so that will be -2, and cosine at pi by 2 is 0, so that's basically 1 plus 0, so that's giving me a negative number. So this is a negative function, will be decreasing. If I plug 3 pi by 2, cosine 3 pi by 2 is a negative, so this is a negative positive, and this cosine theta at pi by 2 is again 0, so that's sort of give me again positive 2, so that is a positive number. So therefore the function is increasing, f is increasing on the interval 0 to pi by on the interval pi to 2 pi, and f is decreasing on the interval 0 to pi. So I have two more problem for you guys to practice on. This is the quiz number 1, in which you have to find the largest interval where the function is decreasing. And I have one more problem for you to practice on, in which you have to find the point where the function changes the sign, changes when it start from decreasing to increasing. This is the end of the video. Thank you very much for watching, and if you like this video, subscribe my channel and hit the bell button so you can get my next video. Thank you.